Science Made Simple with Mr. Sani.
Hello students, today we want to look at friction. Friction is defined as a force which acts at the surface of separation between two objects in contact and tends to oppose the motion of one object over the other. The effect of friction force cannot be felt unless the two bodies are in motion. That is, before you can feel the effect, the two bodies must be in motion. This is the force that opposes the motion of the two bodies. It's also the force that causes the movement of the two bodies. In some cases, the frictional force has to be overcome before the body can move. To demonstrate the effect of friction, we can make use of a wood rectangular box and a spring balance. That rectangular wood box must be made in such a way that you have a narrow side and a broad side, and then you make some sides to be smooth and some sides to be rough. Then place the smooth side of the rectangular box on the smooth surface and attach a spring balance to it. So you place the smooth side on the smooth surface. Then you put the spring balance in such a way that the effect of the wood, rectangular wood, will be felt. Then you apply a gentle pull to the spring balance so that the wood will start to move. You notice it, you record that force in the spring balance. That is the limiting force the rectangular box has to overcome before it can start moving. Any additional pull on the spring balance will cause the wood to move with uniform velocity. That is to say, to make the wood block move, you have to overcome the frictional force between the wood and the smooth surface. When the wood is about to move, when you feel that, okay, this thing is about to move, that is the limiting force, the limiting frictional force that will require by the wood to move along that plane. Any additional force will cause the movement of the wood. We have two types of frictional force, or we have two types of friction. We have one, the static friction, 6 to 5. The second question says that what is the total force of the static friction? Just as I explained earlier on, is the friction is the maximum force that must be overcome before a body can start to move over another. That is the maximum force required by the body to overcome between the surface and the body before it can be moved. That static friction is also called limiting friction. So we also have the dynamic friction. That is the force required by the body to be in motion, to be in uniform velocity. We call it dynamic or kinetic friction. So from this simple experiment I explained, we can deduce that friction opposes motion. Friction opposes motion. It also produces motion. You understand? It opposes motion. And then friction is independent on the area of the surface. Friction is also dependent on the nature of the surface. We can also deduce that friction is proportional to reaction. As we have the frictional force that will keep the body going in this direction, there's also an equal and opposite force according to the Newton law of third law of motion. We say that action and reaction and reaction. If the body moves like this, there's another reaction that will keep the body move in that direction. That one is opposite, frictional force. So we have here that we have our frictional force is directly proportional to the reaction. So from here we can deduce that our frictional force is equal to new reaction. New here is called the coefficient of friction. New is called it's a constant which is called coefficient of friction. For static friction, we have our nu to be coefficient of static friction. That is the force required by the body to start moving the body. While in the other one, dynamic friction, nu is called the coefficient of dynamic friction. That is the coefficient that will keep the body to move in a uniform velocity. I want to look at the advantages of friction. One, it helps to work or stop working. That is, with frictional force, we can work easily and we can stop working because there's friction between our foot and the ground. Two, it enables automobiles tires to make a firm group with the highways. That is, there must be good friction between the tires and the highway so that the motor can move very well. Without friction, the motor will not be able to move on the highway. Friction is also utilized in farm beds used over wheels or pulling in machinery. That is, the farm bed are attached to the machinery. So we use friction to make the farm bed work freely. It enables a screw or nail to remain in place after screw into the position. That is, the friction also allows the nail or screw that is attached to a wood to stay in that position. Number 5, it enables the brake to stop the car. That with frictional force, the brake can easily be applied on the car to stop the car moving. So even though because of friction, the car will just be going. So but if you apply brake, frictional force enables the brake to catch the tire so that the car will stop moving. Frictional force is also used in the grindstone to sharpen knives and shears. That is, there must be frictional force between the grindstone and the knives so that it will sharpen the edge of the knives or chisel. The disadvantage of friction are as follows. It leads to wears and tears in the machine. As we know that frictional force opposes motion, it also produces motion. As the edges in contact, the surfaces in contact, as they are rolling over each other, it will cause wears and tears in the machine. Gradually, the thing will be diminishing in size. That is the wear and tear in machine. It also causes loss of energy in machine and therefore reduce the efficiency because as you are moving the machine, you use high energy to overcome the frictional force. So therefore it causes loss of energy in the machine. Therefore, it's going to reduce the efficiency of the machine. Friction also causes heating of engine because as the surfaces are rolling over each other, there will be heating. It will emanate. If you rub your hand against this board very well now, we experience heat. So the same thing, when the two surfaces are sliding over each other, there's going to be heat, and it's called the heating of the engine. Method of reducing friction. Friction can be reduced in the following way: by using lubricant such as oil, grease, and gravite. You can use it. If you apply oil, it will reduce the friction, it will reduce the wearing, so it will allow free movement. We can also use ball or roller bearing to reduce friction. The ball or roller bearing, it will enable the smooth movement of the two surfaces. You can also use streamlining of the body shapes in such a way to allow the movement. So, in streamlining, that's by shaping a body to the streamlines of the fruit through which it is moving. So, that is also is going to retard the force and reduce the friction. Now, I want to look at some ideas on circular motion. Circular motion. I told you that you have different types of motion. Among it, we have rotational motion. And that rotational motion is the motion of a body in a circular direction. An object moving with a constant speed along a circular path is said to have a uniform circular motion. That is, for instance now, if you while a stone at the end of a rope, you attach a stone at the end of the rope and you while it in a circular direction so that it moves in a circular path. Let's say we have the stone here. This is a rope. This is a rope. So, and you while it so that it moves in circular motion. It will form a circle. This circle, now let us pick a segment of the circle. Let's say the stone move from here to here, from point P to Q. Don't forget, this rope is moving at circular speed, regular speed. The speed is regular, is uniform, but as it moves in the circular direction, the velocity changes because velocity has to do with direction. It has a regular speed by rotating around, but the direction, velocity at each particular point of the circle varies, because here now you have the velocity here. Here now, if you move at the velocity here, the direction has changes. Here is in eastern direction, here is northern direction. So let's say the stone move from the point P to Q and sustain an angle of theta from P to Q, and R is the radius of the circle. From here, we can see that the acceleration of this movement now is directed towards the center. The acceleration that will keep the object to move at regular rotation is what they call centripetal acceleration. Centripetal acceleration for the circular, we call it centripetal acceleration. This acceleration is v square over r. V is the velocity and r is the radius. The acceleration here is directed inward, and it keeps the stone to move in a circular direction. From the calculation, we can also have our centripetal force. Centripetal force is the force that will keep the object to move in circular direction. This force is directed towards the center of the body. So our centripetal force is going to be mv square over r. From our method, from our formula, we have m is equal to A. Since M is here, and our A is V square over R, so our centripetal force is mv square over R. The stone is assumed to move from point P to Q, sustain an angle of theta. The time for the movement is T. It moves from P to Q and sustain an angle of theta. The radius of the circle is R. Now, this PQ is the length of the movement. To generate the angular velocity omega is going to be, velocity is equal to displacement over time. So now it's going to be the angle. The angle is going to be theta. We call this one angular displacement over time. The angular velocity is represented by omega is equal to angular displacement over time. But angular displacement itself is the length of the circle, the distance of the circle. That is S over R is distance of the length of the arc, which is represented by S over the radius of the circle. That is angular displacement. From our conventional linear acceleration, we have is that our velocity is equal to distance over time. Our velocity is equal to displacement or distance over time. But from here, we can see that our S is equal to R theta from this expression. So we can put, instead of writing S now, we can say our V is equal to R theta all over T. This will give us we can simplify this as saying that our V is equal to R theta over T. Theta over T. Our V is equal to R theta over T. And theta over T here, theta over T is the same thing as angular, so it will now be R angular velocity. From here, we can see that our V is equal to R omega. So this V is equal to R omega is the relationship between the linear velocity and angular velocity. This V is linear velocity. This one is angular velocity. The relationship between the two is equal to V is equal to R omega. Example 1. A stone while at the end of a rope 30 centimeters long makes 10 complete revolutions in 2 seconds. Find the angular velocity in radius per second, the linear speed, the distance covered in 5 seconds. Now, from here, from the question, we are given the rope at the end of a rope 30 centimeters long. That is the rope, the radius is 30 centimeters. We can easily convert that one to meter, which is 30 over 100 meter is 0.3 meter. It makes 10 complete revolution in 10 seconds. that is 10 revolution in 2 seconds, rather, in 2 seconds. 1 revolution, for 1 revolution that is 360 degree. 1 revolution is 360 degree, or 2 pi in radian, because we are asked to calculate it in radian per seconds, not radius, in radian per seconds. So that is 1 revolution, which is 360 degree. The 360 degree is the same thing as 2 pi in radian. For 10 revolution now will now be 10 times 2 pi. 10 times 2 pi, which is equal to 20 pi in radian. That is, we have that 10 revolution to be 10 times 2 pi, which is equal to 20 pi in radian. And it took 2 seconds to make that 10 revolution. So the angular velocity will now be the distance 20 pi over the time. That is the angular displacement over time. Angular velocity is equal to angular displacement over time, which is equal to 20 pi over time. This one will now give us 10 pi in radian per seconds. This answers the first question. We have 10 pi in radian per second. You can simplify it further by saying that our 10 pi is the same thing as saying 10 3.142. You know, pi is 322 over 7. So 3 times 3.142 will give us 31.4 radian per second. So our linear speed, the second question, our linear speed, since we know that our linear speed is the same thing as r omega. The relationship between our linear speed and the angular speed is v is equal to r omega. Our v here will be equal to r, which is 0.3 meter, 0.3 meter over omega, which is 31.4 in radian per second. That is 31.4 in radian per second, which will now give us 0.142 meter per second. V is equal to 0.942 meter per second. The third question is the distance covered in 5 seconds. As we know that our velocity is equal to distance over time. So now the distance covered in 5 seconds is going to be S is equal to VT. Our V from the last calculation is 0.942 and our given time is 5 seconds. So the final answer is going to be 4.71 meter. Another example, a mass of 10 kilogram is moving in a circular path of radius 2 meter with a uniform speed of 50 meter per second. Find the acceleration and the corresponding centripetal force. Now, from the question, we have the mass of the body to be 10 kilogram. It's moving in a circular way. We have the radius to be 2 meters. With a speed of 50 meters, we have the speed to be 50 meters per second. Find the centripetal acceleration, A, to be found, and the centripetal force, F, to be found. From our previous knowledge, we have centripetal acceleration to be equal to V square over R. Centripetal acceleration, the formula for it is centripetal acceleration is equal to speed square over R. Our V here is what? 50. That will be 50 square. And our R is 2 meters, is 2. So this 50 square is the same as 50 times 50 over 2. So our A now will now give us 1,250 meters per second square. That is centripetal acceleration. We also know that our centripetal force, the formula for is Ft is equal to ma. We know our A here. So our centripetal force will now be our mass is 10 kilogram times the acceleration 1,250. 12,500 Newton. Newton is the unit for force. Now, a block of wood weighing 4 Newton is placed on a horizontal table. It is then pulled by means of a spring balance attached to one of its ends. The block just begins to move when the spring balance records a horizontal force of 2.5 Newton. 1. What is the coefficient of static friction? 2. What is the frictional force when the horizontal force of 2 Newton is recorded by the spring balance? From the question, we have a block of wood. Let's say this is our block of wood weighing 4 Newton. The weight will come down. 4 Newton. Weighing 4 Newton is placed on a horizontal table, a table like this. Let's say this is horizontal table. It is then pulled by means of spring balance attached to one of its ends. Let's say it is pulled, spring balance attached here. It is pulled. Let's say this is the point of the spring balance. It is pulled by means of spring balance attached to one of its ends. The block just begins to move when the spring records for a total force of 2.5 Newton. 2.5 Newton. Because that is the force that has to be overcome before the movement can start is 2.5 Newton. That is static friction. Now, what is the coefficient of the static friction? From here, if the weight add downward is 4 Newton. There's also an equal reaction to the weight reaction, which is also 4 Newton, according to the Newton third law of motion. Action and reaction are equal. This is the weight downward, then the reaction upward. Now the frictional force that will cause the movement is 2.5. Don't forget that we have our equation F is equal to nu R. Don't forget that equation. From here we have our F to be 2.5 Newton and our reaction is 4 Newton. You are asked to calculate the coefficient of that be, from here we have our coefficient of the friction to be F over R, which is equal to 2.5 over 4, which now give us 2.5 over 4. It give us 0.625. No unit, because F is in Newton, force is in Newton. So this cancel this. It's going to be 0.625. The second question says that what is the frictional force when an horizontal force of 10 Newton is recorded by the spring? Don't forget, we are told that the frictional force that the movement, the body must overcome before it can move is 2.5 Newton. Now, they are now saying what is the frictional force when the horizontal force? That means with the horizontal of 2.0 Newton, there can never be any movement. It requires 2.5 Newton for the body to move. So since the frictional force is 2.0 Newton, so what is the frictional force when the horizontal force is 2.0 Newton? The frictional force will also be 2.0 Newton. That is the frictional force between the body and the surface. But there cannot be any movement because 2.0 Newton is less than 2.5 Newton that is required by the body to move. A car starting from rest accelerates uniformly and attain a speed of 80 meters per second. A car, let's say we want to draw velocity time graph now. This velocity time. This place is time axis T. This place is velocity axis V. Now, a car starting from rest, that means from 0 here. From 0 here, this is 0. From rest, accelerating uniformly till they attain a speed of 80 meters. Uniform acceleration like this. Till it attains a speed of 80 meters per second. 80 meters per second in 30 seconds. This place is in seconds. Time is in seconds. This place is meter per second. This axis meter per second. This one time in seconds. So a car starting from rest accelerates uniformly like this and attain a speed of 80 meters per second in 30 seconds. That is the the grammatical representation of the first statement. It maintains this speed, this steady speed, for another 30 seconds. That is, when it gets the speed of 80, it maintains this speed for another 30 seconds. That means this speed will be 60. 30 plus 30 will give you 60. It maintains the speed for another 30 seconds. It then slows down uniformly. That is, it retards uniformly. Slow down uniformly till it comes to rest in the next 40 seconds. That is, it slows down like this till it comes to rest for another 40 seconds. 40 plus this one will be 100. This will be 100. For another 40 seconds, this place is 100. 40. Sketch the velocity time graph for the motion of this car. That is what I've just done. Now, from the graph, find the uniform acceleration during the first stage of the journey. The uniform acceleration from the graph, this is uniform velocity, uniform speed. So it accelerates here, maintain the same speed here, decelerate here. Acceleration, constant acceleration, deceleration. That's it. So find the uniform acceleration during the first stage. This is the first stage of the journey. First stage, second stage, and this is the third stage. So from the first stage now, we have our acceleration to be equal to velocity over time. First one. Acceleration to be equal to velocity. So here we have acceleration is equal to velocity 80 over time 30. Bam, bam. This one will give us 2.67 meter per second square. That's the first stage for the motion. From the first stage, then done the first of the journey. And the retardation, you should find the retardation, then the last stage of the journey. This is the retardation, the last stage. Using the same formula, we have acceleration is also, retardation is minus A, minus acceleration. That is the retardation. So we have it that our retardation here, though we are going to go ahead and get our answer. Retardation here is from, this is final one, this is initial one. So that is 0 minus 80. Final velocity is 0. Initial velocity is 8. Coming down, 0 minus 80. Change the velocity over time, 40. So this is going to give us minus 80 over 40. You give us minus 2 meter per second square. Deceleration is opposite of acceleration. Acceleration is change in velocity over time. Change in velocity here. This 0 means the final velocity, because the final velocity of the journey is 0. This one is the maximum speed of the journey. So from 0 is going to be final 0 minus initial. Will give us minus 80. The time taken from here to here is 40. From here to here 100 minus 60 is 40. That is the time for the final stage of the journey. So if you divide minus 80 divided by 40, you get minus 2 meters per second square. So how long did the car travel altogether? That's the last stage, last question. This is the second one. How long did how long did the car travel altogether? That is the distance covered by the car from the starting point here, moving here, and moving down. That is how long. From the diagram, you can see that the diagram, we have 3 stages in the diagram. The first one like this, the second one like this, and the third one like this. So the first stage, this first stage, second stage, third stage. The first stage, that one looks like a triangle. The second stage, that one looks like rectangle. And the last stage, that one looks like triangle again. Now, this one is 80. 80 here. The first stage, 0 to 30, this place is 30. 30 to 60, this place is another 30. This place is 40. From 30 to 60, we have 30 here, we have 60 here. Now, to calculate the distance here now, the area for triangle is half base times height. To calculate the area of triangle here, the area of triangle here is half base times height. So the base is 30. Half of 30 times height. Half of 30, that is 15 times 80. This is given 1,200 meters. The second one is the area of rectangle. Area of rectangle. That will be length times breadth. That one will give us, the length is 80 times the breadth is 30. The last stage, that one is also a triangle. The area of that triangle will give us half base times height. It's equal to half of 40 times height. The second one, 80 times 30, will give us 2,400 meters. The last one, half of 40, 20 times 80, 1,006, abi? 1,600 meters. Then the total length, let us add everything together. That one will give us 5,200 meters. That is the answer. That is the total distance traveled by the car from the starting point to the end point. That's 5,200. Alternatively, we can consider that the whole diagram looks like one figure, like this. You have this. It looks like one figure, the whole journey. So from here, this looks like a trapezium. So with the height like this, the maximum height is 80. The distance here from here to here is what? Is 30. While the total time here is what? 100. Now, this is 80. The height is 80. This place is 30. And the other one is, we have 30 here. We have 100 here. We have 80 here. This thing looks like a trapezium. And the area for a trapezium will be half of the sum of the two parallel line times height. Half of the sum of the two parallel line times height is going to be half. The sum of the two parallel line is 30 plus 100. From here to here is 30, one parallel, 100. Then times the height. The height is 80. This will give us half of 130 times 80. It will give us 40 times 130. Half of it is 40. 40 times 130 will give us 5,200 meters. The same answer with the first method. Thank you.